Right then, good morning everybody, and welcome to this Artificial Intelligence in Geospatial, the State of the Science webinar. We're really excited to be hosting this event as part of our Geospatial Insights Innovation Network here at the KTN. My name is Andy Bennett, Space Specialist here, and I will be helping to introduce the sessions and hopefully keeping things to time. Before we get into the core of the event, I want to briefly mention the technical side, which I'm sure many of you are familiar with now. For this webinar, you'll see there is a Q&A function and a chat box. Please use the Q&A function to ask questions of the panelists. Here you can upvote your favorite questions so we know which ones to ask as well. The chat box you can use for general comments, or if you have any technical problems where our excellent events team will be able to help. We will be recording the session and uploading it to our website after the event, so if you want to go back and view again or share with colleagues, then please do. Following the event, we'll be using Meeting Mojo to allow webinar registrants to get a chance to book meetings with each other and potentially the panelists. So a bit of virtual networking, if you like. Meetings will take place between 1 and 4 p.m. today, and each meeting lasts 15 minutes. Our events team and Poonam is now sharing the platform URL in the chat box. It's very easy to register, follow the instructions, and you'll be able to book meetings with your fellow participants. So now back to the core of today. A key element of our role at the KTN is to connect across sectors, peoples, and geographies, and to respond to the challenges and drive positive change through innovation. Business is at the heart of what we do. However, our diverse connections span government, funders, research, and the third sector. We've built a network of innovators, businesses, academics and government contacts to open up new opportunities beyond existing thinking, accelerating ambitious ideas into real-world solutions. Today, we are connecting between artificial intelligence and geospatial, and it's been great to engage with our colleagues' expertise and knowledge through Caroline Chilabusi, Astrid Ayel, and Luca Padello in both of these domains in bringing together today's agenda. So we'll be hearing from some excellent speakers and panelists today, companies at the forefront of their fields, showcasing great uses of artificial intelligence and its impact on geospatial data and solutions. Geospatial data has proven to be beneficial across industries and is being used in many applications, identifying communications gaps, humanitarian relief, cost saving and insurance, among many others. While it's been used in multiple sectors, the true benefit of embedding this data in business innovation has not yet been fully realized, and the complexity and challenges may be poorly understood. Advancements in the application of artificial intelligence to geospatial data are starting to show promising signs of being able to unlock its true potential, and the promise of what GeoAI can deliver is of significant interest to commercial and government organizations. But what does GeoAI really mean? How does it work? What are the challenges? I hope today we can shine some light on these topics with the help of our panelists and speakers. In the first session, panelists will explore AI in a geospatial context to try to demystify some of the technology, look at some of the limitations and explore the current state of the art. Certainly I know when I use the term AI, I know I use it without necessarily knowing its exact meaning. And we're privileged to have some world-class technical experts helping us to get a better understanding of the topic. This panel will be chaired by Andrew Coote from Consulting Ware. The second panel involves practitioners of AI in a geospatial context, and the panelists will showcase some great examples of how they're using AI to get better insights into their data. The panel of SMEs and sector experts are at the forefront of their fields in the application of AI, and this panel will be chaired by our very own Astrid Ayel, who works for our AI for Services Innovation Network. First up today, though, I'd like to introduce you to Charles Kennelly. Charles has been Esri UK's CTO since 2008, bringing 25 years of experience delivering projects of all scales across multiple sectors. Charles's deep understanding of the application of geography helps him find ways of making GIS accessible to ordinary users in wide-ranging environments. From consumer mapping to enterprise and business critical systems, he is committed to reducing barriers to the use of geospatial techniques across society. It's fantastic to welcome you to today's event, and I look forward to your presentation. So over to you, Charles.
Good morning, everyone, and I hope you're all well and lockdown isn't too bad for you. I'm just going to talk at a fairly high level, really, about the state of artificial intelligence and its application to geospatial. I'm not going to go into any great detail because there's many people more qualified than me on that. But I just want to sort of just give a snapshot of how I think it's being used and what the potential is for it. One thing to recognize is, artificial intelligence has been around since the 50s, really, but it's fair to say it's having a moment. It's really come of age in the last few years, driven by advances in the availability of data, advances in information science and data management and computing power. And all those things have come together to really, we're entering a golden age of what is possible with artificial intelligence and with deep learning in particular. The application of geography to that, I obviously find very, very, very interesting because of the role that I have myself. But just before we get into it, one of the best characterizations of what is different about AI compared to traditional information management techniques or computing techniques, it's a very reductive sort of way of thinking of things and probably insulting to people who've invested so much of their life into the understanding and development of AI. But traditional computing is likened to, if you're trying to work out if 1 and 1 equals 2. In traditional computing, you say, I have one, I add them together, the answer is 2, you calculate it. With AI type approaches, you basically say, based upon all the calculations I have seen, I think that normally 1 plus 1 equals 2. It's basically a very different approach. And why it's significant is it lets us tackle problems that we struggled to tackle in the past. It doesn't really let us do anything new, it just lets us tackle things quickly and efficiently so they become possible. In my work, I quite often had customers who would ask us to do things 10 years ago on a project. I'd like to do this in a project. These are my requirements. And I always had a little get out clause when we were responding to these things that essentially said, that part of your requirement is basically you're asking for an AI. You want something to make judgment upon an image or decide something on it that we can't easily quantify in the tools that we have available to us. And effectively, when I was saying you need an AI for that, I was saying this project isn't possible. That's completely changed now. AIs can be used to make judgment about things. They can be used to inform decisions and so on. And it can seem complex and it can seem esoteric, but when you break it down, it's actually, sorry for some of the more advanced people on this, it's relatively easy. This in front of you here, this is Scratch, which is a visual programming environment aimed at children and education environment. And it is an AI that has been put together to basically, I'm just going to refresh this page because it hasn't come up properly. You can train this AI to do image recognition. So I am going to draw a smiley face like this. It knows nothing right now, and it says, I'm guessing it's not. I said, yes, that's a smiley face. And I'm going to draw another one, and I'm going to make it sad. And I'm going to say that is not a smiley face, and I'm going to draw another one and say this. Now, I'm not going to go through the whole thing, but trust me, after about 25 iterations, 30 iterations of this, it starts becoming really, really quite spookily good at identifying what a smiley face is and what it isn't, no matter how much you try and fool it. This is aimed at children in primary school. And if you see the code behind it, it's very understandable. It is not huge. Some of the concepts of AI are not that hard to get into and understand. Fundamentally, it's about pattern recognition and lots of stats. Now, Geospatial has been using elements of AI for quite a long time. This is an example of a large data set of road accidents in North America. And you can see some clusters identified. Those clusters have been identified with some AI tools, traditional pre-deep learning and machine learning sort of tools, looking for clusters. And with geospatial data, we use these sort of tools quite a lot because we're dealing with very spatial problems. But this is an example of where clusters have been detected using if you see this orange cluster here, it has been detected along a road. So it's a little bit different than just saying things are close together, as you see here. It starts to understand that the nature of these clusters are modified by the data around them and the context that they're in. And this is using slightly more advanced AI to do clustering. But here's an example of a cluster that's been detected of incidents, and they've been clustered together. And if you look at it carefully, you can see there's a big difference between this incident and this one. This is on a motorway, and these ones are in car parks. Very, very different. But if we look at it just at a high level as a cluster, we think they're all related. So where AI starts really coming into its own is this sort of thing. So we've run some image detection using AI, and we've detected where things are car parks, are likely to be car parks. Then we can take that cluster and we can remove things that are, or separate out things that are not related, though on the surface they may be. And to me, that's a really good example of the sort of potential we can start to see when we apply AI techniques to geospatial type data. The other thing I find really interesting is the problem space of geography and geographic analysis and AI. That the maths are actually very, very similar when you break down how AIs work. Quite often it's about separating out features into clusters, into groups, so that you can tell them apart. And a lot of the mathematical techniques that are used in that space are actually very similar to things we've been using in geospatial for years. So to a degree, they're always sort of meant to go together. But we can actually get, where I say it really becoming interesting is the area of image recognition and categorization. So this is a very simple example of an aerial photograph, and then some relatively simple AI approach to this allows us to classify that into a more structured map, basically, that we can extract information out and present in a sort of more traditional sort of way. Also seeing a harder problem space is extraction of 3D features. So if you think about the world we're in, it's 3D. Power companies quite often want to tell where their cables are and so on. And the ability to take a point cloud, which has been relatively easy to capture for a while now, but actually extract meaning out of it is a very hard problem. And it's a problem that you can imagine how in this world, people could do that given time. I can look at that image, I can classify things, and I can use it to make better decisions, but it takes time. Extracting meaningful 3D features out of things like LiDAR, point clouds, and so on, and all other types of remote sense data is actually a very, very hard problem and takes people a long time to do. A well-trained AI can automate this process to a high degree of accuracy because it's very focused on a certain area. And I see real opportunity with that. Now, when you step back and think, where could we apply AI to geospatial? The opportunities are absolutely huge. So things like image classification that we just seen, feature extraction was really, really important. If you see this power line here, the sort of things that power companies worry about is if they put more energy through a line, it will sag. And if it sags because it's hotter, it will touch trees. So I need to understand all of that relationship to manage that network efficiently. That's a really expensive process right now. We can automate that very quickly and change the way that these businesses operate. An area that really, really interests me is automatic survey. Going back to the image classification one, if you imagine pouring in survey data of all different types, LiDAR and images and aerial photographs and satellite, they're all coming in to central store. We can have an AI trained to generate Ordnance Survey master map, for example, with no human interaction at all. Basically automatic survey, because the volume of data that's available to us now has never been greater. It's only growing. Managing that and turning it into meaningful information is an increasingly difficult task. By applying AI, we can literally self-survey, pour in data, and out comes a map that we can categorize and use. Or even better, take that information and use it for what you would have used the map for, not actually use the map directly. I'll just come back to that in a second. We can use AI to help us generate better cartography. We can help it with data quality. One of the biggest issues that the geospatial sector faces is the quality of data. Maintaining maps showing you where farmers are farming crops and so on, or where land applications are being made, planning applications are being made, is actually quite hard. Maintaining maps of constraints to development is very, very hard. And maintaining quality of that data is really tricky. The techniques that we're talking about can be used to fundamentally change the level of quality, so we can be sure of the data that we work with and make decisions against. One of the barriers to companies currently releasing data for use, for example, utility companies, are nervous about releasing their data for many reasons, commercial and otherwise. But at the core of it, there's two issues they really worry about. One is liability if somebody uses their data to make a decision like dig somewhere and it turns out that they weren't correct. And the second one is equality. Can the data we have sustain the questions that people are asking about it? I see AI as being a way of really helping in that thing. Data precision is another one. We've seen the use of AI recently to take features such as telegraph poles, and the companies involved managing these telegraph poles, they know where they are, but they don't know exactly where they are. So they have points that represent these poles, but they're not entirely sure that they're in precise locations. So what we're seeing them doing is take image recognition techniques and then analyze the images to look for the poles they know are there, but refine that location right down to precise centimeter level accuracy. And if you combine with that sort of thinking with IoT and the sort of emergence of IoT devices, you can really see how we can bring all these things together to create better quality data. On the subject of IoT sensors, we're starting to see things like edge devices where if you're managing a building, it's really important to know how many people are in a room. But using image recognition for that, the images can be quite large and people worry about privacy, which I'll come on to again as well. So what we're seeing people doing is running image recognition in a camera in a room, looks at the room, counts how many people are there on that device, and the only thing it sends back to the central system is there are 4 people there. So privacy is maintained and bandwidth is reduced. So some very, very interesting things happening in this area. However, we've got to be really, really careful with the use of AI tools, because a bit like a few years ago when people were talking about big data or the cloud, they are terms which are very overloaded. They can mean anything, and businesses quite often use them to absolve themselves of the need to think about things sometimes. So we've had customers in the past come to us and say, our database is too slow, our queries are too slow, we want to use big data. And you talk to them and it becomes quite clear that they don't know what they mean by big data. What they mean really is we want our problem solved. In that specific case I'm talking about, we indexed their existing data and it worked fine. We're seeing that same thing with artificial intelligence. Companies think it's easy, it can solve every problem that they have. And as we all know, it can't. Having access to artificial intelligence does not remove the need to consider what problem you're trying to fix, to have data that supports the question that you're going to do, and have data of the right confidence levels. So there's a real need for caution about what is the role of AI and how far can it help. And we saw earlier the very simple smiley face, not smiley face AI. It's a relatively simple thing to train. You can get good results out of it, but its use case is very limited, and it wouldn't sustain use outside of playing and understanding. If you have a problem that you want AI to solve, like positioning telegraph poles accurately, you need to have data that you can use to train that system properly. And companies consistently underestimate the difficulty of obtaining data to train AIs that can answer the question that they're hoping to answer. The work involved can be as significant as a major IT project today in traditional areas. It can be multiple millions of pounds. The output is very powerful because it can do things like self-survey, it can generate information straight away. But we just need to be cautious about AI is not a magic bullet. It's a tool we can use. It's a very powerful tool. It's got huge potential, but it has its limits. The other thing we've got to be really careful of is the wider perception of AI and spatial data. If any of you have read Neuromancer by William Gibson, classic novel, sci-fi novel, it talked about, it was written, I think, in the 80s, and sort of speculated about the future of the internet and so on. Much of what it talked about came true. But there's a scene in that where there's an artificial intelligence, and it's trying to track a person. And as this person is walking through an airport, each phone, as they walk past, they go past a bank of telephones. Each phone rings in turn because the AI knows precisely where that person is. And it's a deeply creepy, unsettling scene in the book because it feels really intrusive if people know where we are. Around COVID-19, we've seen quite a lot of stories around the world of awareness of people's location leading to invasion of their privacy. This headline here I find fascinating. AI is biased. Here's how scientists are trying to fix it. Now, we all know AI is just a tool. It itself is not biased, but the data we feed it quite often reveals our own biases or society's biases. So if people, the general public and so on, who may benefit from some of the techniques we're talking about, if they are not accepting of the benefits and nervous about what it's doing, it could be a real barrier to the adoption and benefits we could see from this. So we have to be very conscious about privacy in the context of geography and in the context of AI, because the very powerful nature of that combination, AI and geography, could be deeply intrusive and very, very unsettling, which can become a barrier to its adoption. So no matter what we're doing, we need to be aware of that aspect, and really be aware of our responsibility to ensure privacy and ensure appropriate use. So that's just something it does actually concern me, because I see it as a potential future barrier on growth. As an aside, I recommend, if you want to understand more about that subject, this website here is a really good read. I can send it the link afterwards, which explains why AIs can be biased and digs into some of the sort of theory and everything behind it. So just to be a bit more positive, let me just show you this little video. So this is an example of geospatial AI that I find very, very interesting. So it's a company called Mobileye that at Esri we've been working with. And what they're doing is using sensors in a car to understand what it's looking at, using simple object detection to detect people and place them in this context. So as you can see, they're driving along and you can see people walking past, and it's categorizing pedestrians and so on. And then you can see this on the map on the right, they're all being located. So, and I like the fact that when we go along here, you'll see some example of good jaywalking going on. It's people like this and so on. Now, what's interesting with this is it's capturing data using AI and camera, which is great because you get a count of people and so on. And then we're translating that into geospatial information. And what we can then do with that is we can use it to understand a lot more. So this technique has been used to work out the impact of roadworks, for example. If I put a roadwork here, does that push more people to be walking along the sidewalk, and are there more likelihood for accidents? It allows, this has been applied in a few cities now, and it allows real insight into how the road network works and what the impact of things like roadworks or diversions or changes to traffic restrictions can mean in many, many areas. And I just really like that tying together of AI image recognition, sort of, you know, in camera being applied to geospatial in a geospatial way, and suddenly you can start understanding things a lot more, because the geospatial aspect gives us the network. We know how these roads, it's not just a picture with some people in it, it's a picture of a place with people at a place in the context of a network. That's what geospatial brings to the picture. It understands the context in which things happen, and then the AI aspect of it makes sense of what we're seeing. Tie the things together, and you can change the way cities work. You can change the way so many sort of industries can work. So it's a really exciting time. We have an ability to work with data at a scale that we could never do before, and that opens up just huge opportunities. I just want to show you the sort of one last sort of.
Charles, we might have to stop you there just because we need to.
Oh, sorry, I did. Okay, I told you what my time.
Yeah,
let me just summarize. There is a lot of opportunity here. Geospatial is a very tricky area in terms of the scale of the data and the complexity of it. And we've got many techniques that have helped us work with that over the years, but we've been held back by that complexity. AI is a tool that can really help manage and understand and get insight in complexity. Put the two together, and I think we've got a huge opportunity. And I can see many uses for it, and they're developing rapidly. But I also see that we need to be cautious, and we need to put it in the context of the wider society that we serve. Thank you.
Thank you very much, and sorry to cut you off there.
Okay.
Over to Andrew now.
So, Charles, thanks very much for that. And I think maybe we can pick up on some of those other things later on. My name's Andrew Coote. I'm the director of Consulting Where. We're a specialized consultancy working in the area of where, basically. And I talked to Lucas some time ago about this GeoAI conundrum to me, in that every presentation I seemed to hear during lockdown, AI was the answer. And I really felt that it wasn't being explained And Charles has certainly given us a good start there in what that really means, and particularly the terminology. There's no drilling down really below the level of this is AI and it'll solve all the world's problems. So what we really want to do in this first panel is to try and demystify particularly some of the technical terminology. And I've got a good panel of people to help me do that now. So if you can put up the next slide, Charles, Luca. So what we did was we posed to our panelists a series of questions, and these are them. Big data, Charles has already referred to. We hear quite a lot about TensorFlow and PyTorch as software tools, and perhaps we'd like to understand whether that's really the whole story. People talk about the graph. What does this mean? Is this a graph database? How is that different from relational? What exactly is deep learning? Charles put up his first slide there. He had a series of Venn diagram type bubbles around AI, deep learning, machine learning. Let's try and unpack that a little bit. What does computer vision bring to geospatial? And particularly, I'm going to ask Natalia to enlighten us on that. Charles has introduced the topic of training algorithms. I mean, algorithms taking longer to train than the size of a major IT project. I think that's going to be an interesting question to discuss. Who are the philosophical gurus in the AI space? Who should we be listening to in terms of where it's going? When will there be general AI solutions? Charles has made the point that a lot of our solutions at the moment in AI are point solutions. They solve a particular problem, but they don't really give us a set of tools for solving general problems. Why neural networks important? And perhaps when we get to Khalid, we're going to ask him about 3D data and why really that presents so many different challenges from the 2D data that perhaps we've been used to. So let's now move on to our panelists. Charles is going to join them, but we're going to have a few introductory remarks first of all from Khalid and then from Natalia. So if I can introduce Khalid, and perhaps we can throw up his first slide. Khalid sits as the chief scientist at Sensat, a leading applied AI with engineering company. He has 20 years experience in applied artificial intelligence within the spatial analytics, data image processing, context reasoning, and pattern recognition fields. So with that, over to you, Khalid.
Thank you very much, Andrew, and thank you very much, Charles. That was a great introduction. And
we need your slides, Khalid.
I will put the slides up as well. That was a great introduction. Some of the really big challenges that you highlighted about survey data and 3D data, and I'll try to talk about those probably in the panel. But before that, coming from Charles's very pragmatic use of AI in real world applications right now, to jumping onto a sort of a dream world that what we want is the artificial general intelligence. And then the question that was posed to me was that when will it be available? Everybody's trying to work, well, most of the organizations trying to sort of dream about this general intelligence. So I thought I'll share something very super high level, but what is this general intelligence and what we're trying to actually achieve? So we're obsessed with artificial neural networks. We've been obsessed with them for quite a few decades. Started off, as Charles mentioned, in the 50s. But what we're trying to sort of work towards with these neural nets is what we call artificial narrow intelligence. All right. So what they're good at is solving one problem, and they will solve that one problem probably with superhuman capabilities, image recognition or classifications like smiley face, non-smiley face, or even more complex object recognition and computer vision. They could recognize languages. They can play chess. They can play Go. They can beat the best Go player in the world. But that's one algorithm doing one thing and doing one thing very, very good. That one algorithm would not be able to do multiple tasks. It would not be able to do computer vision and beat the best chess player in the world. So the generalization it's always been a problem. One AI algorithm or set of algorithms that could solve multiple or a very holistic complex problem. That's what we're trying to achieve. And that's what really the general intelligence speaks of. So the artificial general intelligence, it will be smart as a human. It would be able to make decisions that require a lot of holistic, complex solutions across the board, not just one tiny little problem. But then there's another bit that we actually don't speak much of it, and is beyond that AGI, and that's also known as artificial superintelligence, machine consciousness. When the Terminator hits us, when Ultron becomes available, there's a lot of sort of existential risk, sort of debate around these topics. So where we are at the moment, we're here. We're at the narrow intelligence part. In fact, it's my personal view that we actually don't even have intelligence within our AI or our deep neural nets. It's pretty much very, very optimized automation. Something that humans can do, but AI can do it much more optimized manner. So question, when will the AGI be available? Oh, it depends on who you ask. You ask Jeffrey Hinton, one of the gurus in the AI world, they said, we don't know. You speak to organizations like OpenAI, they come up and said, oh, we should have it in the next 10 to 15 years. But the rough ballpark is that we will get some sort of generalization happening within our algorithms around 2030. Or even some sort of intelligence being added into our algorithms in 2030, 2060. We tend to sort of predict that we will get the whole AGI working algorithm as smart as humans, making sort of optimized decisions. Super intelligent? I don't think anybody knows. Just to give you a very, very brief sort of, this is what AI is doing right now. It's robotics, it's AI. I think it is fantastic. It's funny, but there was a goal. So moving from that to a bit more on the computer vision part, a few years ago, we tried running object recognition on our very high resolution 2D orthomosaic images. And the results were, it thought the trees were broccolis, right? But we've moved on. We can actually recognize, as Charles showed as well, that we can recognize these objects pretty well. Then Charles mentioned that the object recognition in 3D is quite a complex thing, and these are some of the results that we've been working on. Since that we capture a lot of our high resolution 3D and 2D data using drones. We could generate a lot of 3D models. And at the moment, the results that are coming out they're absolutely fantastic, that you can actually start to sort of recognize individual objects at some sort of granularity. Existential risk, I mean, as soon as you talk about AGI, the robot is taken as the destroyer, but that's not the case. I mean, I'm really looking forward to sort of seeing the applications of AI where there's holistic solutions to it. Instead of a smart city, there's a conscious city that can actually optimize itself. Instead of just an autonomous vehicle, there's an autonomous traffic network, and so on and so forth. So I'll just stop here, and then we'll have the chance to ask more questions later.
So thank you very much, Khalid. That's an excellent quick whiz through general intelligence, and perhaps you're suggesting we don't really need to worry about being replaced as a species for perhaps a little time yet. I think the other good point that's been made around here is this whole business about the importance of training, and I hope that Natalia may be able to help us with that. So if I can introduce Natalia just very briefly. She's the co-founder and CTO of Deep Planet. Her research focuses on applications of state-of-the-art machine learning methods and artificial intelligence for pursuing sustainable goals. This includes defining areas where machine learning tools will be especially advantageous within target related to climate change, sustainable agriculture, water and food scarcity, as well as monitoring progress towards market adoption of new AI-based technologies in agri-tech. So a lot of really big problems that Natalia is focusing on. So I'd like to invite her to just do a brief introduction. Natalia.
Thank you very much for introduction, Andrew. And it was really great to see previous talks. It's very relevant to applications of sustainability, obviously. Just a few words about my background. I have background in computer vision, so that's why I will be talking slightly more about computer vision applications. So we have learned already today what is AI and what is machine learning and what is deep learning. And the applications I'm going to cover like somewhere here in the deep learning and like one of the most sophisticated and hard to compute models out there in geospatial. So typically a model will look something like that. So when we're talking about computer vision applications, we're talking about how to build this complex structure with millions of parameters to be able to get insights of what we are seeing. In many cases, like here, we not only want to understand what we are seeing and classify the input to the model, but just create semantic segmentation. So this picture is just mostly to scare the audience. So I won't go into details here, and I will just speak a little about the applications of these things. There are a few pitfalls in deep learning models, so why it is difficult. As I have shown before, we have millions of parameters, and to be able to get insights from the data using the models with so many parameters, we really need a lot of data. And in many cases, we just don't have this data in geospatial. So in order to extract meaningful insights, we need to use applications of combining both satellite data from multiple sources if available. Other sources of information, for example, if we're talking about agriculture, like information from agronomists, some field data, some historical data, and only then combine all these in machine learning models to provide meaningful interpretation of this data. But nonetheless, there are tons of applications that can use these models, including crop detection and yield forecasts, vegetation health prediction, crop monitoring, water monitoring, and other very useful and important applications. So just to highlight a few important applications of computer vision in geospatial, I'd like to talk about semantic segmentation. So what is semantic segmentation? Semantic segmentation is an application when we take an image, and for each pixel in the image, we say what it is. Is it water? Is it land? It is agricultural land, or maybe it is a road. Interpolation is when we have readings or labels for a few distant points and we need to interpret a few points between them. This is very useful, for example, for agricultural applications when we have sensor readings and we need to combine it somehow with satellite data to give an overall picture of what is happening on the land. The most classical models that are used in all the sustainable applications are sequence models, when we use historical data to provide insights on what is going to happen, or forecasting. And finally, probably the most recent invention in this kind of applications is generative models used in geospatial. Here we speak about models like variation autoencoders or generative adversarial networks, or GANs, that are used to create data, new data for training, or fuse the data from multiple sources, for example, from different satellites, In Geospatial, it's not very easy to fuse the data, for example, from Landsat and Sentinel, because they have different bands, they have different resolution, and this is very difficult. So what we can do with these kind of models is we can extract information about the inner representation of some bands of satellite image and use them together, combine them to create this large number of data points to use them in the model. So for example, we can use earlier Landsat data and like the Sentinel data to create a large data set that spans over 10 years. So the variety of applications, specifically in computer vision, that we can use. These applications combined can allow us to do things like tree monitoring on a very large areas like country scale or a continent scale. Do interpolations for soil moisture sensors for crops and sustainable agriculture to minimize, for example, water usage or nutrient usage. To predict soil moisture from satellites without using sensor actually. Or for example, do land surface temperature estimation, which is quite a difficult task, and it's not very accurate yet, but we're working on it. And for example, do things like rangeland monitoring when we monitor large territories of grass to get insights how we can move the cattle between different blocks to avoid overgrazing, for example, and to predict what will be the biomass of grass on a very, very large territory when there is like flooding, or for example, when there is drought on the large territories. So there are a lot of useful and interesting applications, which are all dependent on our correct usage of data and ability to augment the data and use different sources of data. Speaking about jumping to very different topics. So all these applications are very, very top of the edge of the research in deep learning and AI. And to be aware of what's really happening there, you need to be constantly monitoring what's happening there in science, what people doing, and probably the most interesting people to follow are the following three people: Jeffrey Hinton, Yanli Khan, and Yoshua Bengio, who are referred as godfathers of artificial intelligence. And probably they are the moving engine of AI in the whole world. But probably whom to follow and whom to listen to is not the correct question to ask in AI. A better question would be what to follow. And in the recent years, it's more important to follow the events and the conferences rather than people, because some of the conference, for example, a neural information processing system, it has like over 10,000 of participants from all over the world and cover all the high-end development in AI and machine learning. So I would say here now in AI the question is not whom do we listen to, but what do we listen to? And for example, neural information processing system this year is going to be fully online, and it has ridiculously low fee. So those who are interested, please attend. It's an amazing event. Thank you very much.
Okay, Natalia, that's great, and I loved your categorization, semantic segmentation, interpolation, sequence models, and generative models. Personally, I found that a very useful way of being able to classify and categorize what we're trying to solve here. So I'd like to now open this discussion up and to invite comments from the audience. I see we've got one or two that are coming in. What I'd first like to do, Luca, if you can, is just throw back up the slide that I put up on the questions, and then we're going to fire some of those and some of yours at the particular panelists. So, Luca, if you can do that, that's very, very useful. But I'm going to start off with one from the audience, and it says, I've always wondered what are the specific challenges in using machine learning for spatial and geographic data. Is there anything that makes ML for spatial data more challenging than other applications? If I feel most of what is presented is essentially pattern recognition, image recognition from a technical point of view. So would one of you like to pick up and deal with that? Charles?
Yeah, I don't think there's anything particularly different about spatial data. In fact, because we have such a wealth of feature data like location of utilities and poles and parcels and so on, it actually can make it easier to label data than it can do in some of the other sort of areas. So, creating labeled data is like fundamental to getting good answers out of an AI, and I think it actually is a bit easier in geospatial than in some other sectors.
Okay.
So, yeah, nothing inherently harder at all.
Okay, no, that's useful. We sometimes think spatial is special, and perhaps it is in some ways, but in many ways not.
Yeah.
So another question from the audience here: a lot of discussion about what AI is in future applications, which is great. But I wonder if anybody can suggest a platform or an app that uses AI and is available to the end user of the geospatial sector. And I guess that takes me to the question we posed about TensorFlow and PyTorch. Natalia, I don't know whether you as a practitioner would like to take a stab at your tools that you use in your work from a software point of view.
Thank you very much for the question. So speaking about TensorFlow and PyTorch, so this is really dependent on what you are doing and what is your concrete goal. So from practice, PyTorch is far more flexible and it allows dynamical computations, where in PyTorch allows dynamical computation, whereas in TensorFlow you actually need to first pre-build graph and then compute it. So this is kind of a privilege of PyTorch here, and this is why it's very, very good to use it for research. On the other hand, for implementation, TensorFlow is easily to deploy in practice, and it's more compatible with practical applications. So basically what people do very, very often, they develop models in PyTorch and then translate them to TensorFlow to deploy them. This is kind of strange thing, but we're adapting quickly. So hopefully there will be more recent developments on either PyTorch or TensorFlow. About the platforms that use AI, multiple platforms that use AI for different applications, but I would say they're very niche. For example, you can find platforms that uses AI for crop segmentation, or like a land surface segmentation, or classification. Some very, very simple machine learning methods can be embedded in like ArcGIS/QGIS type of applications, so like KNN type of models. So there are multiple things and tools using AI, and they're like growing very, very quickly. There is a multitude of startups who are developing AI platforms for different usages, such, for example, specifically for transportation.
Okay, Natalia, that sounds like an ideal thing for people to maybe hook up with you this afternoon through this meeting mojo, because I suspect that you could spend a lot more time going into detail on that. So thank you for that.
Thank you.
We've got a question from the audience here from Paul Massara. In the short term, where do you see the biggest commercial applications of AI and spatial data? And perhaps, Khalid, you'd like to pick that one up?
I would be more than happy to. We're in that domain, and we've got a software startup that's actually working on one of what we think, hopefully, is the most commercially viable application of AI, and that's in the sort of large infrastructure sector. So construction and maintenance of assets, recognition of assets, and be able to do a lot more sort of progress-related work and predict if the construction projects and these large infrastructure projects are going to be sort of, either executed on time or how to save cost and money and time itself. Most of the construction projects are not on time, over budget. So introduction of AI within these commercial sectors, especially infrastructure related ones, would be a great example of where money really is.
Okay, that's great. And thanks for keeping it short. I'm sure that's one that people interested in that sector will be getting on Meeting Mojo, hopefully, to set up something with yourself. The next question from the audience, it's for Charles, and it's the mobile eye example. How do you know the exact location of the people? I can see how the rough position of the vehicle can be used, though interested to understand how that infers the location of the people. Charles, over to you.
It's an interesting one because on the project that video was done for, the role of Esri was actually about the location aspect of it. So as you say, the camera is seeing the people, but the camera doesn't necessarily know precisely where it is. So in that one, we actually did a lot of work on, there was sensitive location data in the cars itself, and then we used that combined with knowledge of position and road and so on to refine the location. It was a dedicated piece of work, and without that piece of work, it wouldn't have been possible to exactly locate them. It was still only located to within a few meters, but right now it is quite a difficult process to precisely locate people. What we're looking at is using the image recognition to identify buildings and so on, and be able to say, if you're looking at those buildings, you must be here. And that's a really exciting area.
It's absolutely fascinating, isn't it? There's just so many applications, which actually sort of leads us on to the next question here that I've got. How can you maintain a competitive advantage as a geospatial company? It sounds like having better AI will accommodate this. So would you like to pick that up, maybe, Khalid?
Yes, I sort of attempted to type the answer as well. But look, it's not about better AI. AI is just a tool. It's like a hammer or a screwdriver, what you use it for. I think it's very important to realize that all of these algorithms are eventually problem solving, right? If you want a commercial advantage, you go close to the client, find out exactly what they actually want the solution for, and then give them something that solves their problem. It doesn't really matter. I've seen an example. It doesn't really matter if you sell them an AI, you sell them a solution. And then if AI is part of it, then that's just where I think we believe that the AI is going to create a lot more sort of solution creating sort of algorithms.
That's excellent.
Can I add one thing to that, Andy?
Yes, yeah, please do, Charles.
I think anything which makes geospatial more accessible, easier to use, more relevant, and cheaper is fundamentally a good thing, because it gets to a wider thing. And we've seen that the more available geospatial has been, the better our business has done, even though the price point has dropped, and the competitive advantage in certain areas is no longer there. Overall, it's a good thing for society and for people to do geospatial.
I think, to me, one of the really key things is that what the pandemic is accelerating is digital transformation, and a lot of the things that we're talking about here are really, really good inputs into that accelerating digital transformation, and perhaps at the very highest policy level, this is perhaps where we're missing out at the moment is articulating how what we're doing around geo and AI is really, really important to the future of the planet, to making us efficient and reacting to the kind of challenges that I think, health challenges, that long term the pandemic just brings to the surface. So we've got a lot of questions coming in, which is great. Can any of the panelists argue on the case studies where traditional ML, e.g. random forests, XGBoost, etc., is preferable to neural networks? Now, this, I think, plays into you, Natalia, so perhaps you'd like to pick that one up.
Yeah, sorry. So I have, thank you very much for the question. So as I have mentioned before, neural networks and deep learning require a lot of inputs. For example, we need, like, starting from minimum 400 data points to train a reasonably large neural network and not to overfit it. And when we have, for example, crop yield prediction problem, we will have data over 10 years and it will be like 10 data points. And even having other different input features, we cannot make or invent too much data here. And here we would prefer to use somewhat smaller models. For example, for crop yield prediction, we use random forests, which work amazingly well. So other consideration is how much do we need to interpret what is inside the model. For example, random forests or regression models allow some sort of interpretation what is happening inside, and when it's really, really crucial that we know exactly what each parameters mean. We would prefer some applications where the parameters sound somewhat interpretable rather than neural networks.
Okay, thank you for
Can I add that very quickly?
Yes, please,
something that we actually played around with recently. It was just a play around that very similar to Charles's data set about accidents. We actually took some of the UK accident data sets and we tried to predict where the accident is going to happen. And as I said, it was just a hackathon play around, and not just prediction of the accidents, but of the severity as well. So eventually the algorithm was predicting where you're going to have an accident and where you're going to die, a fatality. And I'll tell you that the best model that we actually used was a simple regression that could actually work really well to it. It wasn't about the deep neural net. So it's just, sometimes it is as simple as a regression model can actually work for such things.
I mean, this is fascinating because, you know, it isn't something completely new. A lot of this is stuff we've been doing for a long time. It has got elements to it, but a lot of it we shouldn't think we need to throw away.
And I think it's just really important to know, like Carla talked about, it's just a tool. There are lots of tools in the toolkit, and knowing when to deploy which ones, and they can be used in series as well. So some of the pre-steps might be one set of tools, and then you go into a machine learning or deep learning model and so on. It's not a, you know, it's a toolkit.
So, I mean, you know, coming with spatial inside, to me, still seems to have relevance, because picking those tools and bringing them together, Charles, is something that you need domain expertise for. So I think that's encouraging that we're not all going to be thrown out of jobs by robots. I'd like to pick up on Neil Ackroyd has made a great point here. It would be great to hear of any applications in Geo using AI that have been deployed at scale, i.e. at national level, that don't include single entities like trees or solar panels. Who would like to pick that one up? I'll throw it open to the three of you. All right, if you're not going to come forward, I'm going to throw it at you, Charles.
There's a few that we're working on with around fraud detection at national scale. So this was some of the larger financial organizations, and a few around the intelligence sector that I'm aware of.
Yeah, so I think that those sectors will push the boundaries, and that coming out then into the wider sector often takes a year or two. So I think, was there anybody else waving at me to answer that one? Okay, I'm going to move on to the next one then, because I know we're running out of time, and I'm looking at you, Andy, to tell me when to stop. But there's just so many interesting questions coming up here. In Australia, we have big issues about knowing where our utilities are. How do you convince people in that space that an AI solution could help identify their utilities. Khalid, would you like to pick that one up?
I think the question actually is a really good question, because it's not just about identifying utilities, it's about convincing people. I think the AI part, there's a lot of trust building that still needs to be done in the industry. We consider AI or any sort of machine learning algorithms to be a magic box that we throw something at it and it's going to give us the answers. That's not true. Charles talked about the bias that we can actually introduce. So it's very important that whenever we actually have any type of asset recognition via utilities, we pass back some sort of a confidence value, that confidence level, some trust value that you can actually say very, very sort of openly that, look, this is the accuracy, or this is the trust value or the confidence value that we've actually recognized these objects. Please verify it. And obviously, validation methods are already in existence that can actually quantify that trust.
Okay, that's great. Charles, I've just got a final one.
On that previous question,
yeah.
One of the best things you can do is use the tools to show people where their current data is wrong and help them correct it. And that can build up their confidence much quicker than showing them where it's all correct.
Okay, and then I've just got two from my list before that. I'll take my prerogative as the facilitator. Charles, the first one is for you. It's the graph. What does this mean? Why are we throwing away object relational, or should we throw away object relational models and replace them with graph databases?
Okay, well, there's two graphs. There's graph databases, and there's a graph used inside neural networks that Natalia can talk a lot more eloquently than I can about. The former, graph databases it's just another way of storing data. No, you don't throw away relational data. It's another tool in the kit. Graph databases are databases which simply store information about the connectivity between things. And to a large degree, the knowledge you have of geospatial, and especially geospatial networks, that's what graph databases are. It's a formalization of stuff we've been working with for many, many years. Some data sets work better in graph data sets. Some data sets work well being transformed from relational into graph and back again. It's just another way of representing data.
But it seems to me, Charles, there's maybe a little bit less sort of mathematical concepts around that. In relational, we had Chris Date put a lot of the maths behind relational, and we started to believe in that. It doesn't seem there's quite the same level of confidence. It feels to me often like, well, we just chuck all of the data in there, and then we'll use some clever indexing to get the same answer. That's a controversial statement, maybe. I mean, Natalia, I don't know whether you have a view around these kind of things, or would you prefer to pass on that one?
Just before Natalia goes live, this is the last question, then we move on to the next panel. Thank you.
No, I prefer to pass on this one since we're out of time.
All right.
If you're happy to book a meeting with me, I'm happy to answer all the questions in the details there. These are not very simple ones.
Okay, well, Luca, thanks for keeping us to time, and I'd really like to thank our panelists there. Fantastic keynote, Charles, and a lot of really good practical advice, which was what I was hoping we'd get out of this panel. So thank you very much. I'll give you a clap. That will have to run for the rest of the audience. So thank you, Luca. Back over to you or to Andy.
Thanks, Andrew. That's great, and thank you as well to our panel. Many thanks to Charles, Khalid, and Natalia, and to Andrew for chairing that excellent discussion. So now on to our second panel, which is focusing on some of the applications of AI in geospatial. So I'd like to welcome my colleague Astrid to the floor to introduce the session and the panelists. So over to you, Astrid.
Thanks, Andy. Hi, hello everyone. So my name is Astrid Ayan, and as Andy mentioned, I am the Knowledge Transfer Manager for Blockchain and FinTech at KTN. I also support the Industrial Strategy Next Generation Services Challenge and its network AI for Services. It's another KTN's innovation network, bringing together AI and data businesses with the professional and financial services sector to support the transformation of the UK services sector. So I'll pop a few links on the chat for you to find out more. But this morning, I am delighted to chair this panel to share some of the amazing applications of AI in geospatial and its potential to drive positive change in our society. So lots of amazing examples that we have. Before I introduce you to our speaker, please do use the QA box, like in the last section, to ask your questions, and I will reply to those at the end of the presentations. So to kick off our panel, may I introduce first my dear colleague Caroline Cibelucci, our Artificial Intelligence Knowledge Transfer Manager. Caroline will be presenting on the use of geospatial analytics and AI on reducing volume crime. Caroline, over to you.
Thank you very much for this. I just want to share a case study which I will demonstrate the power of WHERE and AI in reducing volume crime. But please be aware that all information used in demonstrating this case study is synthetic, just because the case study itself is quite sensitive. So everything which I'm talking about here is picked from the internet, and it's nothing to do with the true thing, but you get the concept, which is the true concept. So the power of WHERE is that it normally actually supports the criminals as well as law enforcement. And I will start to pose as a criminal how they use the power of WHERE to conduct their activities. I will first of all discuss or give a definition of volume crime. Volume crime includes all these items: shoplifting, car theft, burglaries, bike theft. And that one, normally funds high levels of crime, and high levels of crime includes terrorism, drug trafficking, and all other big things like that. But in this particular case, I would like to focus on the bike theft, which was a massive problem at some point, where millions of bikes were stolen in the UK, and the police were overwhelmed with the amount of work to follow them up and try to track down what is happening. So I will pose now as a criminal person. The first thing which I would do is to Google quickly to find out the cycling clubs. And in this case, I chose a random one, which is called Cannock Hill Club from here. And when I went to their website, I found this picture. Finding this picture means that I can understand that there's nice bikes there to nick. And I go and check, and I find that these bikes are actually over £3,000 each. And that makes me much happier because I know that there is something here for me. Right. Something has happened here. Right. And then I will go again to look at the properties which are around that area, which is Cannon Hill. And then I'll find that there is houses which are quite expensive there, which is telling that people who are living in that area are wealthy. Looking at their garage, you will know how to get in. And then the next item is to understand where to take the bike after having it. Obviously, there is auction sites which are quite open there for any criminal to sell their stuff in there. Previously, it was very easy for criminals to take the bike and change the color and sell it on eBay or Gumtree. But now it's becoming much sophisticated, and they are selling them, they're taking it and break it into parts and sell it. And that is where the police started to become a little bit uncomfortable, because the work was becoming complex. So going back to the law enforcement, they have a database of people who are reporting things which are stolen every day. The database is quite huge. This is only a few columns, but there's more items on it. When the bike is solid and it's not into parts, it's very, very easy to follow it up and identify the stolen bike from the auction sites, because there's these features. For example, you take the items or the characteristics or the explanations from the police database, and you match it on these features here, like that. And there's telephone numbers and location of the seller, and those ones normally help the police to identify things. There's another item which is very, very interesting, which is seller's description. So if you look at the description of the victim to the police, if you match it to the description of the seller, for example, if there's something which is saying there's a mark or something like that on the bike, then it's very, very quick that we can match this using natural language processing to understand that this is the same bike. Even if sometimes they have changed the color, sometimes it's very, very easy to match these descriptions and identify the criminal. The problem started when a lot of bikes were reported and that they were stolen, but we can't find the bikes on the auction sites. The number of bikes which were there were much, much smaller compared to the number of bikes which were reported. And so we started to look at bicycle part shops. We saw that the numbers are high, and that is where we started to understand that there is a problem here. The problem is that the bikes have been stolen and then they're broken into pieces. And that is where we started to use natural language processing to understand similar description of the selling of these parts. And then using also image processing to understand how they position the picture of the part. You might find that the same picture is on the different sites with different addresses of a seller. But when you do the image processing, you can understand that this is the same picture. And then the other thing which we did is to understand also the seller's location, why you can find that the locations which are chosen are similar in characteristics. For example, you find that the locations where the seller is putting the address on the eBay is got the houses which have got big garages, for example, which will act as a workshop and also as a storage area. And when you see these characteristics and go deep into it, using image processing and natural language processing and other items, you find that this is the same person, but is using different locations to do this type of criminality. So you can see that there's police database on all these items which can come in. The very, very good thing about Where is that there is selling address, there's item storage addresses, there's seller's movement where you can track with mobile phones, and also there's seller's bank account, the location of it, it can tell you quite a lot. In there, using all this information, you can start to understand, or you can pick up the patterns using AI, that same seller selling the same items from different location. Residential houses with big garages are used to do this type of criminality, and also connection with a known offender in the police database. This is very, very common actually. You find that there's someone who is connected somehow, and that is how the police normally starts to follow after having all this information. So that is what I could say. Thank you very much. And that's the power of WHERE and AI.
Thank you, Caroline. We actually have Jonathan Crook as part of our attendees, who is working for the police and government on countering criminal activity and is familiar with what you've been talking about. So he'll be interested to speak to you later on this afternoon. But I just wanted to ask a couple of questions before we move on to the next speaker. First, what do you think can be done to improve the identification of these criminal activities?
I think the best thing, which I think we didn't do in the first place, was to use the movement. And this is where the power of WHERE, to use the movement of this person using the mobile phone and also combine it with CCTV. That would have been much, much easier because you could see the bikes coming in and going out, or people going to, using the trucks, going to take them to the post office and all other things. So that maybe could have been much faster, and it could have improved this, the process of identifying this problem.
Yeah, very good. And I know of your interest in and expertise in the adoption of ethical AI. Data ethics is indeed a rapidly emerging area, and increasing those collecting, sharing, and working with data, exploring the ethics of their practices. I think it's specifically important when talking about, in identifying criminals. So in your view, which data ethical principles are of particular importance when using geospatial analytics and AI?
I think is that thing where you don't use data by looking, for example, using data which is unnecessary data. For example, there are people who use data from the postcodes and start to assume everybody who is in that postcode is a criminal, and that is wrong to do that, and that is bias. Americans are using this type of techniques. It's not a very good thing. We just used what we need to use. For example, we used the information which is on the database, police database, to say what is stolen and how it is, why is it like that, is there a dent or something, what is the color and everything. And then we used also information from eBay to match. We didn't go outside there to look for data which is going to predict things which we don't need to.
Yes, great. But it makes me think there is a report published by the Law Society on the impact of bias in algorithms. I'll put a link. And we also have we are hosting on the 8th of December a AI mini forum on sharing digital ethical practices within the professional services sector. So perhaps something of interest to our audience. But thank you very much, Caroline. What a way to start our panel. Our next speaker is Ghislain Landry, Head of Data Science at Elemental Concept. Ghislain leads the organization's AI strategy, leveraging the latest advances in AI to help clients create value from their data, as well as auditing AI systems developed by third parties on behalf of potential investors. So Ghislain will be presenting on the use of geospatial AI to improve the recruitment process. You ready, Ghislain?
Yes, thank you, Astrid, for that nice introduction. So in this presentation, I'm going to share with you some of the work we have been doing. Precisely, I'll give you an overview of a use case illustrating how you can use AI and geodata to create value both for your organization and job seekers. I believe it is safe to assume that we are all familiar with the frustration that comes with searching for a new job. From an organization's perspective, recruitment is one of the biggest challenges because they want to hire the most suitable candidate, or let's say the right candidate for the job. I think to better understand this, it is important to look at what recruitment involves. One can think of recruitment as the process of searching for prospective employee and motivating them and encouraging them to apply for a job in an organization. So central to this is there are two fundamental activities, that is the ability to motivate candidate, to find candidate and then motivate them enough for them to apply for the job. The idea being that if you receive enough applications, then you're most likely to get someone who fits the profile you're looking for. Today, this is achieved, these functionalities are achieved mostly through what is called job boards. The job board is basically a search engine that displays jobs to job seekers. So these enable organizations to reach a large number of job seekers. As I said earlier, if you can reach a large number of job seekers, then the likelihood of getting the right candidate for the job is much higher. So how do you get job seekers to apply for your jobs then? So one thing that has been done recently is to allow what is called what is known as one-click applications, where you can simply just in a single click apply to a job. But more importantly, this can be improved. Let's look at how traditional job searches usually work. So typically, you choose a location of where you want to apply for a job, and then a list of vacancies will be displayed to you. This is problematic because passive candidates are unlikely to apply for the simple reason that they have to think of where they want to work and how far they are willing to travel for that specific job. In addition, registers to pick are generally inaccurate and they don't give you enough information into how well or how far, how much time it will take you to actually get to that job, which is a huge component, given that people who live far from their jobs are much more likely to quit than others. So how can we actually improve this? I think we can learn a few things from mainstream search engines. One of the reasons they are so good at what they do is probably because they use some of the information which are not necessarily relevant to the job itself, but that take into account the surrounding of where the searcher is. So how could we use those techniques for the similar techniques can apply to job searches. So how do you do that? The key idea here is to build an understanding of how far or where a job seeker is prepared to travel for a job. So in order to achieve that, you usually start with where the job seeker lives. This can be approximated. You don't have to use the actual address of where they are. This can be approximated, as I said. On top of that, you need to build a profile, which may take into account a number of information, including the type of job, the distance, or the commute time, of target location, availability of amenities such as railway stations, and so on. So that will give you a broad idea of where the location are, and provide you some of the context around both the job seekers and the location of the job. So once you have that, one thing I would typically done is to create an understanding of the latent relationship between where the job seeker actually lives and the location of the job. This can be done through a technique called known as location embedding, which takes it's basically an AI technique that is used to embed or to create a representation of objects in a form that a machine can understand. So in this case, you, for example, use a pairing between job location and the job seeker's location and the job's location, given that they have applied to that specific job. And from that process, you could use a very simple logic, which is similar to the word embedding approach to build an understanding of how likely they are to come to that location. And once you have that, the last step is now to combine that embedding with the user's profile and provide a ranking of jobs. So basically what we're building here is a job recommendation. So you use this technique to recommend job to users, which are in essence more relevant to what they would likely apply to, or based on similarities with other candidates. Obviously, there are some key challenges to this, which are similar to any challenges you will face when building any recommendation system. Is that anything is that there is a chance that you might end up limiting users, job seekers, to a certain category of jobs or category of locations. This is something which is basically undesirable, and while being in these systems, we should be aware of those pitfalls and try to mitigate them as much as possible. The other challenge that may present itself is the work from home. We have seen that the pandemic has changed a lot of behavior in terms of how willing people are to work from home, or how willing employers are to let people work from home. So this might have a significant impact as well, in the sense that you will need probably to adjust these systems to make sure that we're taking into account the fact that behaviors are changing, and for potentially redesign the system or to use something which can self-adapt, which will be able to self-adapt. So this might be the end of our presentation. Thank you.
Thank you, Gisela. Great presentation. Just a couple of questions before we move on to our next speaker. You mentioned in your presentations just now that recommendations need to be diversified. Why is that needed, and how would you ensure that?
Yeah, I think we have. Thank you for the question, Astrid. Yeah, I think we have already seen those kind of behavior in social network, where just based on what we can recommend to any specific individual, you end up altering their way of seeing things or changing their mind. A similar situation may happen with equipment as well. So in order to avoid this, a typical approach is to from time to time randomize what you're providing to users as feedback, as response. So a simple way would be occasionally just listing random jobs that have pretty much nothing to do with their preferences. That way, you ensure that you're not targeting them in such a way that they could be focusing themselves on a specific kind of jobs, as opposed to having a broader perspective to where they want to apply.
Yeah, that is true. And you also mentioned COVID-19 and the impact on our ways of working. Do you think your solution will need to adapt?
Yes, I think there's a need to adapt, because here one of the challenges we have here is that we're going from years and years of data to just a few months, because what I believe that the pandemic has changed significantly the way people behave and their willingness to travel to a specific location for a job. So what we expect is that in the future, there will be a need to reassess these systems, a system like this one, to make sure that it's taking into account new behaviors, which as some of the panelists in the previous panel mentioned, and Caroline as well, this might create bias in the sense that the population is changing and then you haven't adapted yet. So these are things that we need to change, but we need to probably retrain the system in order to take into account those new behaviors coming from the population.
Yeah, well, that's the beauty of AI, isn't it? Is that you can adapt to according to the data that you're seeing, and you know, improve your solution and your product depending on that. Okay, great, Gislain, thank you very much. Our next speaker is Rishi Sap. I'm saying it in French now, every word. Rishi Sap, co-founder and head of product design at Mantel Labs. Rishi has more than 15 years of experience in using AI in the banking and insurance sector. Rishi will be presenting on the use of geospatial AI for the financial inclusion of smallholder farmers.
Thanks, Astrid, for the introduction. So the topic we want to talk about today is how we can provide commercially viable credit and insurance products to smallholder farmers around the world. Now, this is a problem actually which has not been solved for decades, and which interestingly is a market which is more than 95% of the global agriculture and farmers around the world. Now, the question obviously is why. Now, this has happened because financial institutions never had the tools to correctly assess agriculture performance, and as a consequence, they priced risk unnecessary into these loans and insurance premiums, due to which it made them expensive. Now, obviously, when the these products become expensive, the farmers are not going to use them. And then, of course, we had government subsidies which had to be, to come into this situation to help them, make the products affordable. However, we also understand that subsidies can never be the solution for this, and they are pretty inefficient as well. Now, just a minute. So what we have done is, we've pooled our experience of almost 20 years of financial risk management and cutting-edge remote sensing, and created GeoBotanics. Now, what is GeoBotanics? It's actually a breakthrough agri-finance product. It uses satellite data, and it has two amazing engines. And one of these, I think, had been touched upon in the previous panel as well. So which is, these engines are unique to our company. So one is something called TerraGrid. So it's able to, mix multiple kind of satellite data and create a unified data set. And the second one is something called Helios, which cleans out the clouds and fills up the data gaps. Now, once this is done, there is actually a business layer which sits on top of it, which creates these decision indices for the finance industry. And we use satellite data, from last 5 years, 10 years, 15 years, and 20 years to get these results out. Now, this works straight out of the box. There is no calibration required. And like what was being discussed before, this is actually a global product being deployed globally. Now, from the deployments that we've done, so as of now, we are managing around $20 billion of client portfolios across our platform, and on a daily basis, we process around 500 million hectares on a daily basis. Now, because we offer a ready-to-use system which seamlessly fits into our clients' business processes, this becomes a one-stop solution for agri-finance. As an example, I'll just take banking. We cover everything from strategy and planning, risk capital allocation, acquiring the customer, in the live season, doing credit limit management, collections, and of course, portfolio management as well. Now, if you take the example here, now what we have over here is what is called as a level 1 credit score. Now here we look at all these individual pixels that you can see on your screen. And over time, what you've done is, we've looked at the behavior of these pixels and computed what is called as a probability of crop failure for each of these locations. And in a banking scenario, it's also called as a probability of default. Now, in this case, when the application for a loan comes in, essentially we know where the farmer is there present. So we know exactly where the latitude and longitude is available. That is tagged to the application. This lat long is then tagged to the pixel. The pixel is essentially on the screen. As you can see, it's color coded. And for each color, there's a risk process that has been, decided by the bank. So basically, the entire risk lending process becomes completely automated and is very, very precise as well. Now, what you're seeing on the screen is, of course, a nice, green-looking kind of an area. But, there are situations where, the bank probably needs to do business in a situation such as this. It's a very poor area, let's say, from an agricultural risk perspective. Now, it could also be an area something like this, right? So you're talking about an area which has a mixed kind of risk behavior. So the key point over here is, by allowing financial institutions, access to this kind of, risk information, they're able to, compute the risk very, very accurately, and therefore they're able to price the products correctly as well, which never, used to happen before. Now, of course, this doesn't mean, the products or the solutions that we have only meant for smallholder farmers. We have the same principles that we've applied in what we call as a level 1 credit score, which is more of a regional analysis. And we applied the same thing at a field level as well. So typically when we move from, developing geographies to large farms, let's say in developed geographies, the same principles that we have discussed before can be applied here as well. Now, what we've done is we've taken our experience, in the banking sector, and we've extended forward in the insurance sector as well. So the insurance sector, has similar problems. Now, what we have is we have a solution now, which is, is essentially a breakthrough crop index insurance, where in this case, it doesn't need any calibration. Again, as usual, it is out of the box. And more importantly, is something called as multi-peril. So it works, right from sowing to harvest for a farmer. And anything that impacts his crop health, you essentially, take care of it. And like I mentioned before, it's global coverage, and it has, integrated pricing engines, and the settlement process is already built into the platform. Now, as a consequence, what happens is when we deploy this, what you end up with is a very simple kind of a framework. So this orange line that you can see on the screen is nothing but a threshold. So the moment the threshold, the value of the index, the crop insurance index, drops below a certain value, an automated kind of disbursement process happens. And as you can see on the screen over here, the pricing for this kind of a product is extremely cost effective. Now, what has happened is because it's a very cost effective product and there's a lot of automation that is built into it, we've had an interesting change in the market. So what has happened is we also work with a lot of crop input companies and commodity players as well. So a lot of these players have come back to us saying, look, they said the pricing of the product is so low that we really don't have the we don't need the farmer to pay for anything. We'll pick up the cost. So as a consequence, we end up with a interesting product like this. We have, let's say, the crop input company. So in this case, it could be seeds, pesticides, fertilizers, anything similar to that. So what they do is they give the bag and they sell the bag of inputs to the farmer. The farmer simply goes on the app store and he downloads an app. He goes to the field. He takes a photograph of the field, standing on the field. So essentially, we get the geotag. And then there's a small QR code which is linked to the bag of a product that he has, which he then scans. Now, as a consequence, what happens? He enrolls himself into what is called as a loyalty shield. And in the back end, there's, of course, a very nice, fancy smart contract that gets generated. Now, when the crop fails, the farmer really doesn't need to do anything because the system is, constantly tracking what is happening across the entire globe and including his farmland. And essentially, an automatic trigger happens. The contract gets activated, and a digital coupon is issued to the farmer saying, look, you're eligible for an insurance payment or a replacement right now. Why don't you take this digital coupon? You go to your nearest, retailer or distributor. And now that retailer or distributor will replace the bag of inputs that you had bought before for free. Now this becomes extremely interesting from the farmer perspective because he's simply using an app and he doesn't need to worry about what's happening at the back end. But in reality, at the back end, there's a whole fancy financial system that we have developed with our reinsurance partners, and this is what is going on at the back. But from the farmer's perspective, it's extremely easy. It's a simple app to use. Now, as a consequence of using these kind of frameworks, what we've been enabled to do is have these financial institutions now participate in providing insurance and credit to smallholder farmers all over the world. And more importantly, we've enabled them to create profitable products from the business perspective. But also the products are cost effective, due to which farmers can also benefit from it. And what we see happening again now going forward as we go in 2021. This is going to have it is already having and will have a significant impact on the financial inclusion for smallholder farmers all over the world. So this is what I quickly wanted to cover today. Over to you, Astrid.
Thank you, Rishi. Just to have a bit of an idea of the adoption of your technology, volume of crop loans are being assessed using your platform, and what are your plans for this going forward?
So as of now, if you see the presentation, I had mentioned we're managing around $20 billion of client portfolios, across different industries. So if I just break this down to crop loans, so currently we are managing of that around $8 billion is the crop loans that we are managing, and in 2021 we already have signed up very large financial institutions, technology partners and other partners as well. So that is expected to increase to around $30 billion in 2021.
Amazing. And financial inclusion is so important, isn't it? And has been identified as a key enabler for 7 of the 17 UN Sustainable Goals. Could you explain a bit more on how your AI analytics gives direct positive impacts to farmers and rural communities?
Right, that's a pretty good question actually. So what happens is, initially, our farmers, didn't have access to either the credit or the insurance part. Now, what happens is, by getting, for example, access to credit, they are also able to now afford, better quality inputs. For example, they can buy, better seeds and things like these. By looking at from the insurance component, now there's a safety component that is available to the farmers from their financial planning that they can do. So what happens is, they can not only now plan pretty well, but they can look at it more from a long term and look at, how they can extend their farming practices as well. So we've had, farmers in, let's say, in Africa where we work with, they used to primarily focus on, let's say, crops such as maize. But after having, access to this, credit and the insurance part, now that, the base level of food security for them has been taken care of. Now they're thinking of also growing cash crops such as cotton and other crops as well. So it's a pretty holistic impact on the livelihood of the farmers. So not only helping them get some kind of security from the financial and livelihood perspective, but also pushing them towards interesting things like trying to increase the income flow and similar things. So it's pretty interesting.
Thank you, Rishi. Definitely a comment from the audience, a fascinating use case. Thank you very much. And last but not least, may I introduce you to Alexei Polyakov, CEO of Locomizer. Alexei is a scientist and entrepreneur. He studies spatial behavior in life systems in Moscow State University and MRC National Institute for Medical Research in London. And during this time, Alexei developed a concept of positional identity, which became the foundation of behavioral bioinformatics platform of Locomizer. So Alexei is going to tell us what happens when artificial intelligence meets biological intelligence, and specifically the work they have been doing in response to the COVID-19 pandemic. Alexei, are you ready? We can't hear you, but we can see your screen.
Yeah, what about now? Hello?
Yeah, we can hear you now. Thank you.
Perfect. Thank you very much. So thank you much for the intro and for the invitation. So today I'm going to tell you a little bit about Locomizer and our work, and also explain how we use artificial and biological intelligence to help our clients. So Locomizer we have a goal. So we have a goal of the company. We are still small, but our goal is to create and organize the spatial data which is generated by humans, meaning that spatial data we generate its location data points while we use mobile devices where we go around, spend time in places we like, and go in different ABC places each day. So we created the spatial operational systems, we call it, which takes GPS level data from mobile devices, mixed with all knowledge about points of interest of activities, amenities in the physical world, and we create two products. First of all, it's a product called user profiles, and the second product is called audience profiles. The user profiles mean that we have a database of sample users which gave consent for the data to be analyzed and classified. And in this case, we have a unique identifier, which abstract ID, which is linked to the range of affinity indexes to different types of places. So it could be kind of low granular level of interest or affinities, kind of arts, automotive, shopping, sports and fitness. It could be second level, which is more granular. When we select, for example, eating and drinking, we can select a subset of eating and drinking places like bars, fast food, Japanese restaurants, pizza. And there's a third level as well, which is a brand level. So we can also classify the person based on the interest to different brand level locations. So when we talk about the audience profiles, so we use user profiles which we generated before to create the audience heat maps, which tells the most likely places to visit, visited by different target audiences. Target audiences mean the audiences with similar interest to, for example, gyms in this particular case, or different other types of POIs I described in the past. So this is a very highly popular product which helps multiple businesses to utilize the audience data on a map to plan, for example, outdoor campaigns, to put posters where the target audiences spend their time, for city planners to locate products and services, the locations where target audiences, once again, could be found with higher probability. Property developers, they need to understand what to develop in a particular site, once again, based on their audiences and the people and their interests who found in the vicinity of this development site. This is just one example. I mean, it's a real example where we worked with the client to create a heat map of fashionable rich men for one of the luxury brands, where you can see we can create not only target audience heat maps, but you can also do it in a granular level. So we can select work days, weekends, different time intervals. So really making this target audience heat maps very dynamic to make sure our clients can utilize this data in a dynamic way. I'm also going to show you kind of a few recent examples how we work with our clients to make sure this data we generate and produce on a daily basis help them fight COVID. And this is one of the greatest example we kind of our work we've done recently with our partners at Centre for Cities in the UK. So it's called the High Streets Recovery Tracker, where we selected 63 cities in the UK, divided them in city centers and suburbs, and we've been monitoring the distribution of the key audience segments, residents, workers, and visitors in the city centers to see what's going on with high streets across the UK. So you can see, I mean, the tracker is updated daily. I mean, you can also find it on Google it and find it, and you will, it's public knowledge. So every day, since the beginning of February, we've been doing this job, and we can see that the actual distribution of people we've been measuring reflected obviously what's happening with the lockdown, with the governmental measures, for example, Eat Out to help out, and second lockdown. So, and a lot of lessons have been learned during this time. So we know the different cities respond differently, and it also depends on city size and geographic locations, which was very, very helpful to, not only for the businesses, but for the kind of local authorities and local governments as well. to see what's happening with the distribution of people in their own locations. So the data we generated in the high street recovery travel could be mixed with other data sources as well, which is very useful to see how, for example, footfall in the city center reflects the spend and how they are connected. So once again, we found a great link between these two variables, and also we found that actually the footfall, which is recovered greater in small and medium cities, it correlates very well with the spend which recovered in these cities as well, which obviously made a lot of press coverage, media, and people saying that the actual data shows us that probably small cities and medium cities and towns hopefully will lead the recovery compared to the large cities and London, for example, which are kind of currently stagnating both in footfall and spend. So another example in Ireland, where we've been looking more closely at the distribution of people pretty much across the whole territory. And we've been looking at the hotspots of audience distribution once again on a daily basis, which kind of helped the clients to follow the crowd and obviously to plan their business activities according to the new distribution of audiences, which considerably changed compared to the background before the pre-COVID. This is another case which I wanted to show you, which is kind of more closer to the artificial and biological intelligence part we've been doing at Locomizer. It's a digital outdoor campaign case in Ireland, where we were looking at the target audiences in interest to universities, fast food at nighttime, and student hostels, kind of student audiences, and we profiled each digital screen in Finland based on the probability to find these target audiences during different time intervals during the day. So you can see the distribution of student-like behaviors is changing, it's different, and this allowed during the day, and this allowed our clients to use this data and to plan their digital outdoor campaign at the times and the locations where the likelihood to find student-like behaviors is the highest. So how we use artificial intelligence at Locomizer? So obviously, it's currently after the pandemic and during these lockdowns and expecting the new reality to be different. So we really need to have much better predictive models which will help us to forecast distribution of people and different types of audiences within cities and generally across the territory. So this is part of artificial intelligence model we have in our platform, which works with training data like weather, season, day type, events, type of amenities, and we can find in the location a number of amenities. TV programs which are showing during the different times intervals, and we use supervised learning approach to predict what's going to happen next month or and next week and even next day. All this training data has been kind of available in the same, was important the same way before the lockdown, but during the after the pandemic, the type of amenities and number of amenities became critical, because as you know, businesses are closing and hopefully will be opening, but their concentration and their locations will be different, and therefore they will drive the new distribution of people as well. And this is why, once again, the need in artificial intelligence supervised learning in our platform became critical. And we are currently working on the kind of most advanced way of doing this analysis and training our system with the current knowledge, once again, about the distribution of new distribution of amenities. But the most difficult problem out of all is actually the classification of human behavior. So how you classify the real world data generated by a user, how you create audiences, how you cluster different types of consumers in different groups. And this is something where the Locomizer actually started. With my background, I'm a biologist myself, and I spent about 10 years working in the UK Institute to study spatial behavior of cells at the Petri dish to understand how basically our complex organisms are built by cells and how they move from one place to another and what logic they apply to that. So I mean, this is how Locomizer was born originally, and because I had an idea that actually the data we generate using our mobile devices could be interpreted in a similar way which we apply to understand the behavior of other living systems, for example, cells. And I mean, this approach, I mean, we call it kind of biological intelligence, which actually can help us to use the specifics about the ways we behave, which is not the only short-range interactions we are engaged with. So it's not just going to the nearest cinema, but going to the cinema probably far away, but in a particular place which we like and which is surrounded by other types of locations we like. So the long-range interaction is critical to here, and also people behave in a way it's not just attraction. So it's not, we're not going to places where we would like to use some kind of products and services. So we actively avoid places which we don't like. And third of all, it's multitasking. So when we go somewhere, we always think about several things at once, where we can kind of maximize the profit of going in a certain locations. These kind of three variables are very, very important. And actually, yes.
Sorry, but we only have a few minutes, and I just want to make sure that we address some of the questions from the audience. Is that okay? It's fascinating.
Absolutely. I'm already finishing. Okay. So just finishing 2 slides. That I wanted to kind of say that our approach, which we called affinity approach to understanding the human behavior, is very different from all current approaches which are used in the space. So we don't use the nearest amenity or nearest POI to classify the person. So we look further away at hundreds of, even sometimes thousands of POIs to understand how all of them are connected and how all of them influence the behavior of a person. And this we came to the kind of probably the critical bit. So the algorithm we developed in the lab to classify the spatial behavior of light systems, which takes into account all these 3 long-range interactions, attraction, repulsion, and multitasking, is actually very, very similar to the standard artificial intelligence technique or machine learning technique, which is called nearest neighbor, where if you want to classify an unknown object, or let's say it's a human, and if you want to, for example, classify based on the interest to coffee shops, which are we can assume they are red stars, or cinemas, green triangles, then we can use k-nearest neighbor machine learning method, modified in the way which reflects some other aspects of human behavior. For example, once again, to go to a coffee shop, not just because you're a coffee shop lover, but because you're actually a cinema lover, but you may be further away from cinema at the time where you're kind of drinking coffee. So this kind of really excited us, where we came to the kind of understanding of the way we classify people, and in the way that we can utilize a lot of artificial intelligence technique already invented for this purpose. Finishing just this short presentation, it's our flagship campaigns which we've done with our clients, which got a lot of media attention. So the James Whiskey campaign, where we create heat maps of people with interest to pubs and bars, and it's a great success, which shows that actually the biological intelligence and artificial intelligence methods which we apply to predicting the distribution of different types of audiences works very well. So obviously I can tell a lot more about what we do and how we do it, and I'll be happy to either answer the questions now or later on via email or otherwise. Thank you very much.
Thank you, Alex. So there is a question for you on how can your product be deployed on scale, and how will you get input data on scale?
Absolutely, the scale is critical, and for us, and we currently, in terms of the kind of the sample size, so we tend to work with about 1% of the population, which is something, or even more, which is something which was very difficult to get, especially provided the privacy constraint and the GDPR in place. But 1% of the sample size is fine, and we can currently get this sample in almost every market in the world apart from China.
Thank you. I'm just looking at the questions coming in now. Alexei, did you use or plan to use personas as part of your input?
But we're actually creating personas, if I understand the questions correctly. So we have the user ID, which is abstract ID, and all hundreds of indexes which reflect the affinity of a person to different categories of POI down to the brand level.
And perhaps a question also open to the other panelists. But you know, most of your use cases were in cities, and 30% of landmass in UK is unconnected, with no connectivity, no internet. So how do you address geospatial AI accuracy?
Our data is almost evenly distributed. I mean, our sample we use almost evenly distributed because we don't rely on the internet. Means we need to have the internet for the data to be transferred and joined kind of the bigger database. But actually, it's all GPS level. So whenever you use mobile phone and whenever you allow GPS to work on your mobile phone, it's recorded. So therefore, it makes it easier to collect the data in a distant parts of the country. But so we are only limited by the accessibility of the GPS system on a smartphone.
Okay, great. Do any other members of the panel want to answer that as well, or is this something that affects your solution? No. Okay, great. And then I had a question. You know, all your solutions capture really rich data, that, you know, valuable data directly from users, which creates benefits not just in your domain but in others. So what are your views and strategy in sharing this data or part of the data that you collect?
I mean, first of all, I saw the question about the GDPR and consent. The data is completely consented. It's all transparent way of making sure that the users have a way to opt out. But originally they were opted in for that. And so we're not collecting the data. We license it because they are already quite well known and established data brokers which license this data. And also, we don't take any other information apart from mobile device ID and location records. So it's still personal data, but by the way we use our AI and BI algorithms, we actually translate the location records into the abstract profiles. So our user profiles is complete abstract representation of a person, which is not personal data at all. And also, and if you talk about our audience profiles, kind of aggregated understanding of audience composition at any place, it's even aggregated abstract data. So, which means our two products are completely safe to use. So we can share it and we can sell it. So without any legal constraints. So I mean, we are happy to work with anyone, with governmental organizations, with charities as well, as which we do, like Center for Citizens in Town. So it's once again, it's all shareable, transferable, and compliant.
What about the other panelists? What is your views or strategy on sharing the data that you're collecting?
From my side, I would say there's no way that any data can be shared. It's sensitive.
Perhaps between government departments, in a secured way.
Yes, probably that way. The other thing is that there is nothing which is done in a biased way. So it's only for the benefit to protect the society. So we need to look at it in that angle, and we don't want to expose too many things for other people to have benefits from.
Any other views?
Yeah, I would say it mostly depends on what you're sharing for and whether you actually inform users of that, of the thinking behind that. I think that's the key problems we often see is that users are not aware of where you actually process the data and who's having access to it. But I think if you have a secure protocol and a strategy for maintaining that privacy, there's a way of sharing the data such a way that it doesn't actually harm the users. But obviously, as Caroline said, it depends on what data it is and who you're sharing with.
Exactly.
And then Rishi, did you want to say something?
Yeah, so what I wanted to say is, since we are also doing, typical projects at, global scale, so we have certain data which might be useful, both for governments and for, for agricultural experts as well. So what we are proposing to do is not give data at a very fine scale, but, open up certain data that we might have, which might, look at things like, degrading of land, looking at areas where, the agricultural production is, no matter what you do, is likely to drop. So this sort of information, of course, we'll provide it to everybody. Yes.
Great. Well, I think that will be our last question. There are some questions that are directly have been directly asked in the Q&A to our panelists. So I'll ask the panelists to answer them directly using the feature type answer, and you can just answer them directly. But thank you so much to all our speakers. That was a great array of applications of GeoAI in different sectors, and really showing the impact it can have on driving positive change in our society. So thank you very much, and I will give it back to Andy to close the session.
Thank you very much, Astrid. I'd like to invite Andrew Coote back as well. I think he may well have a few comments on the discussion today. But yes, firstly off, thank you to all the panelists, both in this second session and the first session, for really stimulating discussion. Andrew, do you want to say a few words?
Yes. Thanks very much, Andy. I mean, this has been a tremendous session from my point of view. I've learned a lot. I've met people that I probably wouldn't have come across before, and I think there's tremendous potential now for following this up. We've only really started to scratch the surface. Things that strike me, first of all, the spillovers, as economists call them, where an application is developed without understanding that it may have other uses. I can already think through some of the use cases that we've heard of, and there are a tremendous other applications, I think, with all of those. The ethical issues, and I thought Caroline did an excellent job in explaining you only use the data that you actually need, and this whole business of location privacy, I think, is coming to the top of the agenda. The Geospatial Commission has started to focus on this, and I think AI and the way in which that intersects with geospatial can play a role in that. Specific bits, some that reassured me, some that didn't. AI maths is similar to geospatial. That's certainly good to hear. The whole automation by using, which Charles talked about, by using multiple different sources to be able to automate that process, I think is very exciting. Slightly more worrying is that the training of AI algorithms can take as long as a major ICT project. That sort of affects the economics clearly. What Khalid was saying about we don't have much intelligence yet. What we really have is smarter automation, and I think that's maybe a reality check about what AI can do at the moment and what not. And I got lots of deep learnings, if I can put it like that, from Natalia. I'm sure she's got an awful lot more to share from us from her enormous experience. When I look at the use cases, I mean, I'll go backwards on these. Alexei talking about biological intelligence. I mean, I think maybe we might refer to that as human behavioral models, and being able to create a nexus between health, location, and AI, I think is really quite exciting. The huge potential, as Rishi was talking about, in meeting sustainable development goals, using some of the tools that he describes to help access to the millions and millions of farmers around the world to finance, and also to warn them of impending disaster. I think that's a really interesting and valuable global scale use case. Some of the things that Gislan was talking around, how location plays a role in recruitment, is certainly an area that I'd never really thought about, and I can see the power of that. And then going back to Caroline again, the crime process unpacked. Not being a criminal, it's quite difficult to put yourself on that side, and I thought that was enormously interesting, and showed the challenges that the police and also security services have, and that I think is another spillover in that some of those techniques can clearly be applied to other applications. So my final conclusion of this is we've only just started down the journey of increasing this nexus between the AI community and the geospatial community. And I'd like to invite all of those who've taken part to suggest where we might go next with this, so that Luca and his colleagues can consider this in the general sphere of knowledge transfer. So thank you, Andy.
Thank you very much, Andrew, for that great summary. I mean, for me, it's that thing around making that human decision process a lot easier, but the enticing prospect of sometime in the future being able to remove that human decision maker completely could be extremely valuable. So yeah, exciting times, and definitely keen to follow up with the panelists after this session. So just a final few things I wanted to draw your attention to. Yeah, as mentioned, we haven't got through all the questions, but we'll do our best to distribute these to the panelists and get responses back to you. So thank you so much for all the questions that you've suggested today. We hope that if you found today interesting, you'll join our network if you haven't already. We're trying to build this strong network and a collaborative effort to help on this journey to where geospatial data will empower us to have a real impact on real world challenges. So before we sign off, there's a few events. I think Luca might put up a couple of slides now to showcase them. So on the 8th of December, the KTN's AI for Services, so this is Astrid's network, will be hosting a mini forum on responsible AI. So this will share experiences and learnings on implementing digital ethical principles in the professional services sector. There's a fantastic lineup of speakers, including Christina Blacklaws, ex-president of the Law Society of England and Wales, and chair of the Next Generation Services Advisory Board, and Melissa Collett, who's the professional standards director at the CII. The Open Data Institute will also be running a workshop to put into practice the insight brought by the speakers. So hopefully there's a link in the chat box now to register for that. And then on the 10th of December, we'll be running our next event in this program, the Geospatial Insights Innovation Network program. And this one is on augmented and virtual reality and gaming in the geospatial sector. And we've got some great speakers there. We'll be highlighting some of the state of the art. We have Stuart Kent from GEV, Melanie Langlotz from GeoAI Games, and excited to also have Ed Parsons from Google presenting at that one. We'll be running that event in collaboration with Enterprise M3 Local Enterprise Partnership. So we'll be showcasing some amazing regional talent as well in that one, for where the gaming and the space sector are extremely strong. We're also supporting a Horizon 2020 project called UFO, which will help geospatial and AI companies to develop products and services for sectors such as maritime, transport, creative industries, as well as solutions to tackle climate change. We're running some consortium building events in early December, as shown in this slide, and the call for funding will be launched any day now. Just be very aware, this is open to UK companies, even though it's a Horizon 2020 project, and you'll be able to apply for funding even after we've left the EU at the end of the year. Next year, our focus will be more around how location intelligence can help tackle global challenges, from climate change to meeting net zero targets, from building inclusive communities to supporting life above and below Earth. So look out for that. We'll be building a program towards COP26 as well next November. So if you want to get in touch about any of that, Luca and I are available, or sign up to our newsletter. Final reminder on Meeting Mojo, if you haven't already registered, please do so. Meetings, as I said, between 1 and 4 p.m. today, and hopefully the URL is again in the chat box. We look forward to speaking with many of you then. And final thanks to our backroom staff who make all this happen. So Andrew and our comms team, Poonam, who runs today so efficiently and so well, and also Luca Budello, who's brought all this topic together with Andrew. So thank you very much to everyone. Thank you for your attendance, and look forward to speaking to you again soon.